Welcome to the Deep Dive. We take sources, find the core insights, and basically give you the cheat sheet to sound like you really know your stuff.
Yeah, making complex topics accessible.
Today we're digging into a dinosaur called Banji. Lived way back, about 66 million years ago. We've got the science papers, the descriptions.
And some debate, too.
Right. So our mission,
Sure.
figure out what made Banji special and, what its discovery really tells us about that whole late Cretaceous scene right near the end.
Exactly. We're looking at the initial classification, the anatomy, but also these newer ideas that, well, they challenge things a bit. It's a great snapshot of how science works, constantly refining.
Okay, let's get into it. Banji. Late Cretaceous period, like we said, 66 million years ago,
Yep.
just before the big exit for the dinosaurs.
Right before the KPG extinction event.
And found in what's now China.
That's right, near Gansu, Jiangxi province. And the main fossil we have, the holotype, IVPP V16896, that's its official number.
Like its museum ID tag.
Pretty much. It was actually donated by an amateur collector, someone just, interested in fossils.
Wow. Not a professional dig team. That's cool.
Yeah, it happens sometimes.
Yeah.
And it likely came from these rocks called the red beds of the Nangshan Formation.
Okay, and those rocks also date back to that really critical time.
Exactly. The Cretaceous-Paleogene boundary. So Banji was around right when things were getting, well, dramatic on a planetary scale.
Puts it right at the edge. And the name Banji Long, you mentioned it was descriptive?
It is. Comes from Chinese. Means striped crest dragon.
Striped-Crest Dragon. Okay, that gives us a visual right away. So what did it look like? Small.
Yeah, sources say small, lightly built, probably walked on two legs, lived on the ground.
Bipedal. Got it.
The estimate for the specimen we have, which seems to be a juvenile, is about 65 centimeters long, so a little over 2 feet.
Okay, tiny compared to a T-Rex, obviously.
Yeah.
But you mentioned the crest.
Yes, its head was the standout feature. Like other oviraptorids, that family of bird-like dinosaurs, often with beaks, feathers, crests.
Right, the ones that look a bit like ostriches sometimes.
Sort of, yeah. It had a tall crest on its skull, but Banji's had unique details.
Okay, here we go. The unique stuff, what was it?
Well, the sides of the crest had these vertical striations, lines, basically, like stripes, hence the name.
Oh, okay. Striped crest. Makes sense.
And there were also grooves on the top surface of its lower jaw. Plus, its nose opening, the nasal opening, was really long, unusually long, stretched almost back to the eye socket.
Whoa, a nose opening nearly back to its eye. That sounds weird.
It's definitely distinctive, and the original paper, Zhu and colleagues back in 2013, they really detailed what made Banji different.
So what were those key points they listed, beyond the long nose and stripes?
They noted the crest itself was made of multiple bones, the nasal bones and the premaxillae.
Those are the bones at the very tip of the snout, right?
Exactly. So a complex, multi-part crest, not just one solid piece.
Okay, more intricate.
And the back edge of this crest had a sort of step-like shape. Plus those two long grooves running along it, and the diagonal stripes, the striations on the sides.
So steps, grooves, and stripes. Quite ornate.
Very. And that super long nasal opening, the external nares, being so far back near the eye, that was a major diagnostic feature they highlighted, makes you wonder about its sense of smell or, maybe display.
Yeah, what was that for? Any other skull quirks?
A few other things. There was a noticeable dip, a fossa on a bone on the roof of the mouth, the pterygoid. Might relate to jaw muscles?
Mm-hmm. Muscle attachments, maybe?
Possibly. And the lower jawbone, the dentary, had several long grooves near the back on its top edge. Oviraptorids were mostly toothless, remember?
Right, beaks mostly.
Yeah. And finally, some little bumps, tubercles on a shelf on another lower jawbone, the sharangular. Lots of small details painting a picture.
Okay, so a lot of fine points that built up this image of Banji. But you mentioned earlier, science doesn't just stop there.
Never does. Our understanding is always a work in progress.
So what's the newer idea?
Well, this leads us to Andrea Cow's suggestion from 2024. He looked at Banji and another oviraptorid called Corythoraptor,
Okay.
and he proposed that Banji might actually just be a young Corythoraptor, an immature individual.
Wait, really? So not its own distinct type of dinosaur?
Potentially not. Cow pointed out some shared, unique skull features between them. His argument is that the things we thought made Banji unique could just be features that change as the animal grows up.
Things that look different on a kid versus an adult.
Exactly. Ontogenetically variable characters is the technical term, like how a human baby's head is proportionally huge compared to its body. If he's right, and Banji's just a juvenile Corythoraptor,
Then what?
then the name Banji, because it was published first, would technically become the valid name for the species. It would be the senior synonym. Corythoraptor would become the invalid junior synonym.
Wow, okay. That really changes things.
Yeah.
It shows how tricky it is working with fossils, especially if you only have young ones.
It's a huge challenge in paleontology, distinguishing a truly different species from just a different growth stage. It's tough without a range of fossils showing different ages.
Yeah, you really need that whole spectrum, from baby to adult, to be sure.
Ideally, yes.
Ah.
It highlights why finding more fossils is always so crucial.
So for now, how is Banji officially classified?
Well, it's still formally genus Banji, species belong, within the family Oviraptoridae, clade Theropoda, Dinosauria, all the way up the chain to kingdom Animalia, like those Russian nesting dolls of classification.
Got it. Part of that bigger Oviraptorosauria group.
Exactly. And you can find timelines and resources that place it within the whole history of discovering these fascinating bird-like dinosaurs.
Okay, so let's wrap up this deep dive on Banji. We've got this small, crested Oviraptorid from China, right at the end of the Cretaceous.
Distinctive skull, striped crest, that very long nasal opening.
But there's this ongoing scientific question mark. Could it actually be a young Corythoraptor?
Precisely. It's a fantastic example of how science is a process, not just a set of facts. Our understanding evolves.
It really makes you think, doesn't it? This whole Banji-Corythoraptor debate.
Mm.
It forces you to consider how finding juvenile fossils can completely shift our view of extinct species.
Absolutely. And it leaves us with a question to ponder. How many other dinosaurs or other extinct animals we think are distinct species might just be different growth stages of the same creature? It's a fundamental puzzle about reading the history written in stone.